Okay, great. So welcome back, everybody. Yes, yes, yes. We're rolling with it. Okay, so thanks again, Sebastian. And so yeah, so this is going to be our kind of wrap up, kind of general discussion of the course. We're going to provide, an overview of what we learned about today, which is why we're scrambling to put some slides together at the last minute. We wanted to try to digest all we heard about this morning so far, and then also provide some kind of closing thoughts, provide, some additional resources for everybody for after the course. Okay, I've got two laptops. Yeah, so first off, yeah, it's been a great week, and we're really happy with the lectures. I think we all learned a lot. I think Peter and I were just discussing that. I think speaking from the faculty, I think we've also kind of learned a great deal. It was a really productive meeting, and so we wanted to thank everybody for your patience. Of course, we're very happy to host you in Boston. It's a bit expensive. I think one thing that we've learned through this kind of hybrid meeting is that we've tried our best to have like a seamless discussion with everybody, including our on-site trainees and virtual attendees. I think we did pretty well, but I think we could certainly do better on this. I think hybrid makes things a little bit awkward. Apologies for the microphone issues. I think that we've worked with it pretty well. Yeah, hot room, I guess. So I should again, Robert Savoy warned me that the temperature control in this room is not great. I think we have everything on Thinkific through day 3, and I think Anna in the back row has been almost completed. Okay, awesome. Thanks, Anna. So that's one we can cross off. So there's still a couple of unanswered questions on Slack, but we're on it. Tyler, I think, was already kind of relaying some questions to Peter. And again, apologies, the recordings, I want to thank Renzo. I mean, honestly, it was a lot of effort to kind of make these recordings available. Again, as we said, we wanted to remove the Q&A. And so we're 1 or 2 days late, but I think it's actually pretty good. And again, apologies, for the Wi-Fi, although thanks to Sebastian and our help desk for kind of coming up with a very clever solution with the Ethernet. And so again, I think that, we did a lot pretty well. There's a few things that we could have done better. So thanks everybody for your patience. I think everyone's been, very positive and enjoying the experience, but we just wanted to acknowledge these hiccups along the way. But I think we've had I think this last day has been a lot of fun so far. This morning we heard from Anna DeVore, who taught us a lot about, these vascular responses that underlie our fMRI signals. Again, all of our fMRI signals in use today are really looking at hemodynamics. And so the more we can understand this relationship between neural activity and hemodynamics, the more we can appreciate, understand how to relate them back to, relate our fMRI signals back to the neural signals of interest. She pointed out that these vascular responses are not, feedback. They're not driven by some sense of a loss of oxygenation. They're really driven by neural signaling. There's this feed-forward connection between the neural activity and the vascular response. I like to think of it as, don't your favorite sports analogy, you kick the ball to where the runner is going, right? It seems that there are these feedback mechanisms that start to engage the vasculature to deliver oxygen, to the neurons, before the oxygen is depleted. She showed us that there's this shortage of oxygen is not a driving force for vasodilation during increased neural activity. She also showed us that these vessels are pretty smart, right? I mean, she showed us this coordination of, vascular control. She said that the vessels have a little brain themselves, and they are, quite smart and able to react quickly to a neural activity. She showed us that the hemodynamic response is expected to be different across layers and across cortical distances, because of these propagations and dilations along the arteries. This complicates, the kind of layer-dependent hemodynamic response. She also showed us how the resting CMRO2, to her surprise, I really liked her comment about often when she comes up with hypotheses about how the brain might work, I think that we learn the most when those hypotheses are not correct. And the fact that the CMRO2 is largest in the superficial layers, even layer 1, I thought was surprising. I think she made a really nice point, however, that this is during rest, this is in somatosensory cortex, perhaps in other types of tasks, the neural activity, may be seen or in other layers, and it's not always locked to locations of the cell body. So even though layer 1 is kind of cell sparse, we may still see strong metabolic responses within those layers because of the operarization and the other sources, the other requirements of energy in these layers. So Luca gave a really nice talk, kind of summarizing a pretty complicated set of tools. I think very elegantly, he said that there's many ways of extracting relevant information related to some stimulus dimension other than examining the mean amplitude. I think that these multivariate techniques probably aren't applied as much as, I think that we still gain a lot of information from conventional fMRI. And I think that we saw how these techniques can be powerful for laminar fMRI as well. They have been applied to a few studies already, but I think that I'm looking forward to seeing more of this. We saw how these, information about different, feed forward and feedback pathways could be decoded, capturing neural laminar information, processing that's not really visible with percent signal changes. I think this is an important, there's many ways to look at our data, many ways to extract information. We don't always, there's ways beyond this sort of massively univariate approach. And so I thought that was really useful to keep in mind. And of course, Peter gave a really inspiring talk. I really liked, this analogy about neuroscience and standard fMRI, laminar fMRI. I thought that was, a really nice idea. Again, I think that, on the one hand, with fMRI, we're always, kind of jealous of our friends in, looking at small animal models. They're able to get to like really kind of fundamental biology and look, at the microscopic level. But it's true too. I think we have a lot to offer with fMRI. We see across the entire brain. Of course, it's in humans. And so I really like this idea of, laminar fMRI kind of bridging across scales and across disciplines. And that was a really nice analogy. Peter told us about how layer fMRI connectivity can help sort out different neural signatures. Again, still need to think about how to interpret this. I think it was a good idea to sort of catalog what we see, maybe use a light touch in terms of the interpretation, start to understand, what the data are telling us. I think that this is a powerful message. We may not always know how to interpret, but taking a light touch, I think, is a really important message, and that that resonated with me a lot. And why are we doing what we do? How can layer fMRI be useful to understanding the brain? I think that, Peter outlined, many possible avenues of impact in this technology. Again, really an inspiring lecture, and I think really kind of thought-provoking. Okay, so yeah, so what next? So in terms of, let's see, it's not updating. I wanted to take a moment now to kind of reflect on the course as a whole. I think this morning is really exciting, but now is a great time for us to try to kind of synthesize all that we've learned along the past, 4 days together. And so one thing that, over pizza last night, we're talking as a group about, what concepts would we hope that anybody who graduates from this course, what concepts would we hope that anybody would, be familiar with, if you're at a conference and talking to new friends and doing laminar, like what concepts would we think that everyone should be aware of? Maybe you can think of it as kind of elements of laminar fMRI culture. I think everyone should know the bump, right? I think Camille recoined this as the intracortical local maximum. Intracortical local maximum. And so, yeah, but the bump is a quite, a famous feature. Also, actually, I'm really happy. I mentioned the shirt last night during dinner, and really happy to see that Renzo has got the shirt today, which is awesome. I talked to him about, the origins of the shirt. The M, I guess that's, like not, scarlet letter. And so, yeah, learned a lot through that study. The mesh brain, that's another thing that we were talking about at dinner. I think you can see here pretty clearly from, I think, is this from Federico's paper? Yeah, I forget. Or
definitely put a brain biology.
Yes, yes.
E5. I don't know. I think it's from Federico or Lars.
Oh, Lars. Okay.
I think it's
Jans. Yeah, Jan Zimmerman. Yeah. That's the 2001 paper. Yeah. So the mesh brain from from Brain Voyage are quite famous. The Bach principle. We learned a lot about this from Farouk yesterday. I mean, this is something that, I think, I would credit, Bob Turner with really kind of, showing us, teaching us about the importance of, Bach's insights and equivolume principle. As you heard, we use this a lot in laminar fMRI, even though, as we discussed yesterday, it doesn't always make a huge impact, but I think it's true that this is an important element of laminar fMRI analysis. And I think pretty much every laminar study these days is using this equivolume principle. The double peak, I forget, some of us call it the double bump. I call it a double peak. We refer to this is sort of shorthand for the peak in activation, especially in Renzo's kind of seminal work we see across layers of the motor cortex. The vein problem, I mean, the Duvernois data, I think, I've seen some version of this Duvernois data in many different talks. It's kind of shocking. I was talking to somebody recently, this paper's from 1981. It's still kind of, the resource for understanding the vasculature in the human brain. We can talk more afterwards why no one has been able to, achieve this level of detail since then. The canonical microcircuit, this came up a lot. Many talks mentioned this. This is sort of the origin of this kind of simplification that we make that I think is still pretty powerful. These kind of three, I haven't come up with a better name, the super layers or three compartments, sort of really inspired by the canonical microcircuit. And of course, not to forget EPI. I think that, while many people still use 2D EPI, I think that in laminar fMRI circles, you're going to, people hear more and more about 3D EPI. 3D EPI is becoming the standard. And so I think that having some understanding of the differences between the two and the benefits of 3D EPI, I think are important. So these are all things that we're hoping that, came across, during the past 4 days, and a little bit tongue-in-cheek, but I think it's true. If anybody left the course without knowing what the double peak is, we would not have done our job. We wanted to go over, some of the layer fMRI jargon and terminology that you may have heard. Sorry. Yeah, it's funny, right? There's, we've been using a lot of terms, kind of throwing them around without maybe fully defining them each time, right? We have segmentation, in terms of acquisition, acquiring an EPI plane in more than one shot and segmenting the acquisition into multiple individual acquisitions, and segmentation when we assign different tissue type labels to our voxels, segmenting the anatomy. So this is one kind of overloaded term in laminar fMRI, so we need to be careful. I think even in some of our discussions, we're talking about segmentation. I got confused which segmentation we're discussing. Layers, yeah. Well, how do we define layers? We heard from Farouk. We heard, there's different, ways to define layers. There's some debates about cortical depth versus cortical layer versus normalized cortical depth. Many different kind of terminological shorthands that we use. I think the point is that in an article, if you're going to use the term layer, define it. As long as it's defined, I think that the readers and reviewers will understand what you mean. Yeah, laminae. You see this sometimes as well. This is, of course, Latin for layer or layers. Again, as long as it's defined, in a paper, I think that people will be able to follow. Cortical depth, again, a technical term used for layers, to understand, again, the reason that people are cautious about this terminology is because of the complex relationship between depths, normalized cortical depths and layers. And so again, cortical layer, you can refer to one of the 6 Brodmann layers, the Cajal layers, the Bolton layers, the Meinert layers. There's many different definitions. And on the one hand, this may seem like there's some disagreement, but I don't think that's the case. I think that there's a lot of differences across layers that different anatomists, different investigators, seek to or choose to highlight. If we were to define layers based on their function, we already discussed, if this 3-layer model may suffice. And so again, we talked before, not only in terms of cytoarchitectonics, myeloarchitectonics, angioarchitectonics, there's different features of cytoarchitecture that, may be relevant. One separation based on cell size, another based on cell density or morphology. And so we need to be mindful of that. There's no, I think Farouk had made this point, there's no kind of objective definition. And so again, all the more reason to define. Layerification is some jargon that I actually didn't know the origin of this word. And when I heard it, I immediately liked it because it does sort of convey, that, we're almost applying this. We're applying this sort of this layer definition to our data. So I like the fact that it's kind of an active word. That's another term that I think everyone's heard many times now. Bandwidth, one parameter to rule them all, right? We heard from Renzo how much of an impact this has on our EPI protocol. These like knock-on effects, in terms of the gradient, the readout gradient waveform shape, magnitude, ramp sampling, et cetera, as well as artifact level. I think, surprising nonlinearities in terms of small changes in bandwidth can give rise to, big changes in echospacing and even larger changes in the mechanical response of the gradient coil. And with these changes in mechanical response, we see more artifacts, and so as well as loudness, amplification of the acoustic noise. And so yeah, it's a quite important parameter. The Bach principle, which is equivalent to this notion that the volumes of layers, there's a principle here, should be kind of preserved across the folding pattern. I think one of the reasons that the Bach principle is so attractive is that there's not a lot of principles in terms of brain anatomy, and this is one that a lot of people have sort of latched onto. The canonical microcircuit, I think, also discussed already, the superlayer model of feed forward and feedback. Everyone should be aware of this canonical microcircuit. It's been updated many times over the years, and maybe different microcircuits for different cortical regions. But again, something that we should all be familiar with. And of course, oh, here it is. The bump. Intracortical local maximum. I like that. We need to make a t-shirt of that, Camille. So we were thinking, what has really changed? Layer fMRI, as Peter said, it's kind of hit a kind of inflection point to 2015, 2016. Sort of really a lot of publications. Feels like a lot. We're still in many ways tackling some of the same problems that we're tackling 5-10 years ago. But I think that, again, over dinner, we're discussing that a lot has changed in the past, 5 or 10 years. And it's useful to take stock of this to maybe think about how things are going to continue to change the next 5 years, 10 years, 15. I think that there was consensus that, it's not perfect, but gosh, acquisition is really not as hard as it used to be. I think that there's more consensus that I think David Norris put this really well in his, lecture on Monday, that there's many ways to make mistakes, but, if, any sequence, can get the right answer, there's multiple ways to get it right as well. I think we're seeing that the analysis, is not so hard anymore. There's a lot of tools, I think that, this era in which one had to develop tools on one's own is sort of past. I think we have a growing community. We have a lot of tool sharing. I think that no one has to go it alone. However, we still think that there may not be a layer fMRI prep coming anytime soon, although maybe we should advocate for this. But the point is that I think the days of people having to roll their own in MATLAB, I think, are, unless one wants to, but one doesn't have to develop these tools on one's own. And so I'm really happy to see that this is something that really has only come on, available in the past 5 years ago, mostly from efforts from the people in this room. Yeah, I think it's true that, maybe, 5+ years ago, talking about layer fMRI, I think that a lot of people in our community might not know what that means. Certainly there was some work in animal models dating back to Alfonso Silva, Alan Koretsky, important studies, but I think that these days, not only our friends at the ISMRM, but our friends at the OHBM are going to know what we mean. I think that there's a lot more studies coming out, influential studies, high-impact studies that I think most people in our community are aware of. And I think that, I'm not sure if we're ready to claim that laminar fMRI has gone mainstream, but I do think that it's much more well-known than it used to be, for sure. There is a community. We are a scientific discipline. I think that's a fair statement. One thing I'll mention in a few slides is, how we can stay in touch, how we can continue to build this community, and to not just, end, today, but, stay in touch and continue to build, and continue to work together. Yeah, I think we're seeing that 70, it's true, as you said, Peter, 100, 120, there's, gosh, still far fewer 7T scanners out in the world compared to 3 Tesla, but I do think that 7T is becoming more mainstream. I noticed yesterday or recently that, a lot of these talks, people didn't even mention the field strengths. I think for a lot of these talks, the data were 7 Tesla, maybe a little bit of 9.4T, 10.5. Yeah, but it's true that, in this room, I think that 7T is kind of a default. And I think that, we're seeing more and more, not just, centers that, develop methods with the focus on MR physics, more 7 Tesla scanners, in kind of hospitals and psychology departments. Yeah, I think it is becoming more mainstream. Less method methods wars? No, I think I would agree. It's funny too. One thing we didn't talk about, yesterday when we were discussing publications is, this sort of common practice that I think is still there where, yeah, I'd actually love to hear your thoughts on this. And it seems like for many years, any paper that would, propose or use a technique other than gradient equal bold would have to show the comparison against.
And even gradient equal bold.
Hmm.
Even if you publish gradient equal bold, in those days you had to show that and like maybe another method might have been better. Or
interesting. Yeah, that may be true. No, that's a good point. So Renzo was saying that even gradient equal bold, even if you were, publishing gradient equal bold data, or that was the acquisition method, that was used for your study, you may be expected to, or viewers may ask you to kind of compare against other techniques. And so I think that this is changing. I think that there's enough confidence and enough data out there on these other methods. Now, it's of course true that there's many ways to make mistakes, but I think that it's true that there's less disagreement these days. I think we the community is agreeing that any sequence can get the right answer. Multiple acquisition or analysis methods, can also, if they're done properly with the proper, vetting, proper, quality assurance, and looking at the data, I think that there's more understanding that there's no one correct method, either acquisition or analysis, to get the right answer, as long as one's rigorous and watches out for these pitfalls. And we're seeing, lots of tutorials, on how to perform acquisition and analysis. I'll point out some YouTube page in a moment. Farouk mentioned that whenever he shows somebody how to fix a problem, he records it and posts it on YouTube so that other people who have the same problem can benefit. And I think that's very generous. And we're seeing a lot more of these tutorials online. And I think that's, really beneficial to the community. We're also discussing earlier today, lots of resources online. And I'll come to that in a moment. And so, right, so there's been some positive developments, but yeah, we're not all the problems have been solved, and we want to be kind of, apparent, transparent about this. There's many unsolved issues, open questions. I'm sure this is just a small list. There's certainly more. Yeah, we were discussing again, what are the remaining sources of noise and how relevant are they? We heard a lot about, physiological noise sort of varying systematically with cortical depth. Like if we did put the effort into really removing these sources of noise, what would the benefits be? Certainly, thermal noise, but what I'd say is maybe in between the two, kind of structural noise. Renzo talked about artifacts that can occur in the data when you push the acceleration too far. And so we can call these biases or noise, but what are the remaining sources of noise and how relevant are they? I think Renzo made a really nice point on Monday, I think it was, talking about data acquisition. And the question becomes, when our data are never perfect, and we can still, even in data that are messy, that are not as perfect or beautiful as we'd like, there's still a lot of relevant information that we can extract. And so the question still becomes, how important are these, non-idealities in our data, and when do they really impact the conclusions that we draw from our studies? How do we make use of this angioarchitecture or vascular data? This question came up a lot. Farouk and I are, really excited, some of the data that Saskia showed us. There's such, beautiful vascular anatomical data that's becoming available. It seems that, because our signals are all coming from vessels, it seems kind of natural that these data could be useful. But I think there isn't consensus about what's the best way to utilize this. I think we've seen people, like Peter Koopmans, showed really nicely how masking out, these big veins helps a lot. But can we do better than just masking out? Can we do better than just throwing out, these large vessels? And so how do we best into our fMRI analysis? Not clear. And as Peter mentioned, gosh, we have so much data now, so much rich data. There's just so much information. It's almost overwhelming. As you said, kind of expanding, our data to another dimension. And so that's both exciting but daunting. There's a lot that can be done. How do we cut through this kind of high dimensional space of layer fMRI data? On the one hand, maybe we need new tools. Maybe we need to kind of rethink how we're doing these analyses in order to best, utilize these these data. Are 0.8 millimeter voxels, fMRI voxels, good enough? On the one hand, we want, the highest resolution we can get. Oh, thanks. Yeah, I think this is the last time the microphone will go out. All right, thanks, guys. What is this? Oh, yeah, fMRI voxel size. Yeah, our 0.8 fMRI voxel is good enough. And why do we say 0.8? I mean, just to be clear, I think I mentioned this at some point, 0.8 is a pretty good sweet spot. I think for a kind of single shot EPI, most 7 Tesla scanners can achieve 0.8 without, breaking too much of a sweat. I think that, plus it's a pretty good, I think we're still, not limited by sensitivity. But 0.8 is a little bit arbitrary. It's almost what our scanners tell us that we can do. I think that, because of these nonlinearities in terms of performance, because of these acoustic, responses of the radiant coils, sometimes it takes a lot of effort to make a small change in the voxel size. It's a lot of nonlinearity. So 0.8 is a pretty good kind of sweet spot today. I think maybe that will be, that constraint will be lifted once we go to new hardware. We'll cease to be maybe encoding limited. Right now, we can't encode smaller than 0.8. Maybe pretty soon we're going to be sensitivity limited, and then we're going to need some denoising or higher field strengths to compensate. I think, though, that probably nobody in this room would say that they wouldn't want a smaller voxel size. Seeing some nodding, yeah. But yeah, what's good enough, right? I mean, on the one hand, we can be greedy, but is 0.8 good enough? And for some applications, I think it can be. And we discussed, got some nice discussions on Slack about, why is 1 millimeter not good enough, or when might 1 millimeter be good enough? And again, I think we're still not clear about, what's the resolution that's really required. How do these patterns, this is maybe the biggest, how do the patterns of laminar activation that we see in fMRI relate to the underlying neural activity? What's missing from our maps? I think we see a lot of features that make sense. We're discussing, the good news, bad news about what, if these fMRI signals really are reflecting input, that's great. That's a lot of useful information, but that means that maybe we're not seeing output, and so that's the kind of other side of that coin. And so the question is, what are we missing? Like, what's not there? We know that there's a lot of complexity in terms of the neural activity. And so, yeah, we're seeing something that's valuable, but we may be missing something as well. And I think that, one thing that I think we all agree upon is that, yeah, cortical segmentation is still not a solved problem. It's sort of remarkable. It takes too long to get a good segmentation. I think that there's consensus that, starting with the automatic method, and then moving to kind of a manual correction, manual labeling is a great idea. But we're discussing, I think one thing would be great to have, and maybe this is a discussion, Farouk, if we can write down like a set of steps, some kind of clear guidance for folks who want to perform this sort of manual correction, manual segmentation. You're right, that's going to be still subjective. Whoever writes down those rules, their subjectivity will be kind of baked in. But I think that's going to at least help, other groups to at least have some reproducibility and have some consensus on what it means to segment, what's good enough, like, some guidance I think would be really helpful. And so that's another kind of open question, how do we kind of drive that, and something we can discuss offline. And so, yeah, so I think that, as I said, I think we've learned a lot, speaking on behalf of co-organizers and faculty, we've learned a lot. And I think we've learned a lot from your questions. And so I think that we also, as I mentioned, this is our first offering of this course. And so we'd love your feedback. And so we put together a survey that we will email to everybody. I'm sorry, we'll post it on the Slack, and maybe I'll email it to you just in case.
Being posted right now.
Oh, it's being posted right now. Awesome. Thanks, Tyler. Again, just a few questions, optional, of course, but we really, love to hear from you. Again, learning more about, what did you like about the course? What were your favorite aspects? And so please keep an eye out for this survey. We will really appreciate your feedback. So this is the slide that was missing from my morning overview. Again, there's been a lot of activity on Slack. I think especially I saw like a spike during the hands-on yesterday. Here's just one thread that I was following. And so again, I would encourage you to, it's the end of the course. It's not too late to jump on the Slack, participate. We're going to be monitoring this. I think that we are going to be looking for questions that have not yet been addressed. but the conversation doesn't have to end. Feel free to post, more questions. We'll do our best to address them. And yeah, but the point is, somebody asked me, I mean, this Slack workspace, this depth resolved fMRI, which Cheryl Ullman at CMRR set up a few years ago, it's open to anybody. Right. So Cheryl was nice enough to kind of let us sort of hijack it a bit for this course. We added a few of these channels that are dedicated to this course, but it's open to anybody. And so stay on the Slack, continue to post, ask questions, interact with the other folks, on this workspace. I think it's a great resource. Speaking of resources, you may have seen in these sort of interstitial slides that we had circulating during the breaks, a lot of other layer fMRI communities that are open to anyone. There's the layer dinner group, the laminats, which has, so is it called the dinner because I think we were planning to have dinner in Sydney, and but of course that was canceled, and so, but I think it's nice because having it on Zoom is great because it's we can have broaden the audience, open it up to everybody. The recordings of previous meetings as well as the proceedings are on laminats.com. The BID, the Brain in Depth, I went one year. It was a lot of fun, organized by Esther. And so you can see, previous meetings at this URL, as well as I think that she's planning another one. The Maastricht layer for my seminar, maybe I'll go more quickly. I learned, NIH layer for my working group, which is open to everybody, which is awesome. And hearing you guys have been having some good discussions, as well as the layer of my Google group. And so these are resources. Oh, and so Anna has posted these interstitial slides that a few people asked for them. They are posted on Thinkific. So there's lots of great information here. You can access that on Thinkific, but we'll make these slides available as well. And again, lots of resources. I was just saying how much I like the Layer fMRI YouTube channel. There's lots of great videos there. The Layer fMRI blog, Things on Things. Twitter is a great place to go for announcements and to hear about cool new articles. And so I think that, there's a ton of content here, especially, the YouTube channel is awesome. There's a lot of great talks there, including tutorials, as well as, big lectures from, luminaries. And so I encourage you to check out, those resources. There must be hundreds of talks, more. Wow. Okay. So maybe I need to take another look. We also compiled a few, a few review articles about acquisition, about analysis, also book chapter, which is a little bit more recent that we would encourage everybody to take a look at. Also, I put this slide together quickly. I don't know how it came out. Okay, didn't come out that well. I just wanted to point out that there's been a couple of, maybe not so recent, but a couple of special issues that are relevant to laminar fMRI. Isa and Larry put together a nice one on high resolution. Camille and I did one on ultra-high field, which had a few relevant papers. David and I did one that was dedicated to cortical laminar fMRI, which I believe, Peter's kind of inspired us to do. So it was a lot of fun to do this with David. And I think the most recent one was done by Laura Lewis, Luca Vizioli here, and Isa Yakub in Progress in Neurobiology. And I think that a lot of the papers that we heard about today, I think Emily Finn's paper was in the special issue. I think your laminar connectivity paper was in the special issue. Saskia had a nice review article on acquisition. I think Camille, you had a nice review. Yeah, so a lot of the faculty in this room contributed. Laura and I did one on modeling, I think. Yeah, there's lots of cool articles that many of us contributed to. So I think this is a nice kind of more recent special issue for you to look up for more information. And so, so I just wanted to also just thank a few folks. It was nice. I thanked a bunch of people on the first day, and I wanted to thank, again, especially Renzo and Tyler. I mean, you guys don't know how much work that they've done kind of behind the scenes, especially the moderation, preparing these slides. Again, thanks, Renzo, preparing these videos. So there's a lot of work that went on, not only to prepare for this meeting, but to kind of carry it out. And so I just wanted to thank Renzo and Tyler again. And of course, Sebastian's a postdoc in my lab. He wanted to take the course because he's excited about laminar. And we asked him if he could help out with the AV, and he's been doing an awesome job. He's not a professional. You might not know this, but Sebastian, thanks so much. This is not easy, so I appreciate it a lot. Yeah, thanks so much. And I'm glad you're able to attend. And so, and so yeah, so also I got like a quick, let's see. Very nice. So thanks, Brooke, for the awesome camera work. Thanks everybody, for attending. I think that as I said, we've learned a lot. It was great to get to know you better. I think we had a lot of fun the past 4 days, and so, but again, stay in touch. I think there's lots of tools that we can use to remain connected after the course wraps up. As I mentioned, logistics, yeah. So I think that all of the talks around Thinkific, we're going to post the recordings there as well. And again, we can stay in touch over Slack. And so, yeah, but I think that, there's a lot of material that we've digested. And so I also want to give some space, for more questions. We have time. If there are any more questions about the content this morning, or as you've been kind of mulling over the past 4 days, any questions from the audience, again, you can tell we like talking about these things. I would encourage everybody, also our friends on Zoom, any other questions you may have, we're happy